Welcome to Angelholm, Sweden, about an hour north of Copenhagen, and like most European cities, it's beautiful, both the scenery and the people. Sweden has had a great legacy of innovation, design, and engineering, especially in aerospace and automotive. Think of Volvo, think of Saab. But what if you mix the two, aerospace and automotive?
I had a lifelong dream to start my car company and build cars. It started when I was 5 years old. I mean, I got the question always, why do you have this dream? And I couldn't really answer, because I didn't really know. And then I started thinking, so when I was 5 years old, I saw this Norwegian animated stop-motion movie about a bicycle repairman who built a fantastic racing car up on a mountaintop in Norway and took it kind of to Le Mans and won over the establishment. And I was so fascinated by this movie. I remember when I walked out of the movies that I said to myself, that's what I'm going to do when I grow up. And when you're like 5 years old, you don't really think about fiction or reality is kind of intertwined, and you're really impressionable. So I think that kind of what was triggering me to do this, and it's just stuck with me. I was kind of pre-programmed to do this from that day on. When I started the company, I was only 22.
It's incredible.
So I've always had a keen interest for engineering, technical things, and worked with cars and mopeds and boats and electronical things, but I never really studied it kind of officially. So we have, of course, a bunch of engineers here that are trained engineers, but I'm kind of, I don't know, more like an inventor or something like that. So this is kind of our development room for all the carbon fiber parts that we use in our cars. So we have all the technology, all the carbon fiber technology proprietary to our company. We started developing carbon fiber parts back in 1996 for the first time. So we have quite a vast experience of special manufacturing carbon fiber parts for cars. What you can see here is the material that is the visible part of the carbon. It's this kind of a twill weave, and there are different types of carbon fiber. They are unidirectional, different weaves, different directions, depending on the need, the stiffness, the strength. You always want to optimize to keep the weight down and the cost down of the carbon fiber, and to make the car as light as possible. So the tools, I would say, are either made out of, if the tools are large, they're made out of carbon fiber, to make them not too cumbersome and heavy to deal with, and they have exactly the same heat expansion as the part itself, so there needs to be no compensation for thermal expansion. But smaller parts we machine most of the time straight out of billet aluminum. Okay. So here, for example, we have lamp clusters, here we have turbo tubing, here we have a tool for intake plenum. So then we have a lot of turbo tubes made up here. So what you're seeing here is a vacuum bagging process, where we only use the most extreme type of carbon fiber material, which is called a pre-preg from Advanced Composite Group in England. And it's the same material you make, well, again, fighter jets or Indy cars or F1 cars out of. In our carbon fiber monocoque, we actually have aluminum honeycomb inside, and this is very unusual for a road car. I think, well, let's say most Formula One carbon tubs, they use aluminum honeycomb. The advantage of aluminum honeycomb compared to other types of core structures or other types of honeycomb material is that it's very crash absorbent, and it holds the pieces together very well in an accident situation. But the negative side is it's very expensive to work with and takes a long time to implement. And as far as I'm aware, we're the only road car manufacturer with a carbon fiber monocoque that actually use aluminum honeycomb or aluminum honeycomb in the monocoque. So it makes it basically safer and extremely strong, but it takes more time and more cost. But I think in a car like this, that's acceptable. If you look at these two, let's see, well, kind of these two pieces, they almost have the same stiffness.
Yep.
This has the core inside, and this is just solid carbon. So it saves a lot of weight. You maintain the stiffness, but of course you reduce some of the strength due to that it's less carbon, but still it's massively stronger than anything else of the same size, shape, and weight.
Got it.
So what we're seeing here is what we call Station 2.
Okay.
By this time we've made all the carbon fiber bits and pieces and received them from our suppliers. And then we put them on this fixture and pre-fit everything prior to paint to make sure everything aligns perfectly. And if there are any specific customer demands to the bodywork, we adjust it here and custom fabricate parts if there is a need for that. And then we take it all apart and send it to the paint shop.
Is everything painted here?
Everything's painted here.
Okay.
Yeah. I jokingly say that when people ask how much can you customize, and I say, well, if you pay us enough, we can build you a helicopter.
So I must ask, how old are you?
I'm 24.
24 years old, and you're the test driver for Koenigsegg.
Yeah.
You must love it.
I love it. I seriously do.
So this is my first time in a Koenigsegg. Let's see how it does.
Yeah, I can show you how it runs. That's the interesting bit.
Let's see how it goes. And I love the fact that you have your own private runway.
Yeah,
to do whatever you want.
We need that.
So what do we need? That's 100 kilometers an hour right there.
Yeah.
And 7th gear, so the 7-speed gearbox.
Yeah, and now we're like on 1600 revs.
Got it.
So actually on the highway it's quite economic for the car it is.
Yeah.
When you but you don't usually do that when you have 1200 horsepower.
So then we take the parts into our paint department. You can actually see them spraying here.
And is any color possible?
Any color is pretty much possible, yes. We have our own mixing room. We actually even come up with our own paint mixtures. We're very proud of our paint result because we put a lot of effort into it. Let's say the thickness of the clear coat is about 3-4 times that of a normal production car. That adds a little bit of weight, but it also means you get a fantastic gloss and the ability to polish for a long time and polish out scratches and stuff like that. And you get this very deep sensation when you look at the car. There's a lot of specialist polishing companies around the world that work with all these hypercars, and many of them tell us that they really like to work on our cars because they're really the top. What I noticed was that people close the door like this and then they kind of want to walk away. They didn't want to push it down and then push it in, because a two-step motion is not natural.
Especially for a door. Yeah.
You're not used to that. People are used to slamming the door and going, and here you have to kind of push it down and then push it in. So I said there must be a way that can be done in one motion, and that's when I came up with this idea that it's actually not a two-step process. And most people at the time thought that's impossible, because how can you kind of slide in and down at the same time without hitting and getting the rubber seals to seal and so on. And that's where we had to really engineer the whole entry of the car to the movement of the hinge, and the movement of the hinge to the entry of the car. A properly engineered part, when you look at it, looks natural. But to get the complex function looking simple and natural, that's really difficult. So we spent thousands of hours developing this hinge. And it's not only the hinge, it's how it's combined with the whole car. It's the shape of the door, it's the angle of the door seals, it's how the door seals look, it's how it interacts with the roof, how the door interacts with the roof, how it interacts with the body when it's open. So it's kind of a parallelogram here, and then you have a helical cut gears here, a hydraulic damper. The door mounts to this portion here. So when I push this in, you can see what it does.
Wow.
But I'll do it with a slow start because the gearbox isn't finished yet.
Alright.
Are you ready?
Let's go.
So
that is incredible.
So that was 300, and this engine nor gearbox isn't fine-tuned yet.
Whoa!
So it will go better and it will shift faster when it's done.
That's the fastest I've ever been in a straight line. Right there.
So this is basically a normal chassis dyno.
Yeah.
But what's pretty cool about it is that we have the engine management kind of hooked up this whole system. So with remote keyboards, when you sit in the car, you can actually program the engine, see what it's doing, and on these screens we get the power and torque and everything. You can take up to about 1,500 horsepower on these hydraulic brakes. And we use it for tuning cars for different types of fuel for different markets.
Okay.
For example, we had a customer in Brazil who wanted to run on E100 instead of E85, so we made a flex fuel for E100.
Huh.
And then in certain areas they have better or worse fuels. We kind of buy in the local fuel, make sure the car runs good on it.
Do you actually bring the fuel in?
We do, yes.
So.
And then of course we have our own airfield,
Of course.
which is very, very convenient.
For any supercar manufacturer, you just need that air.
Yeah, I think without that we could not do what we're doing, because we can 24/7 we can go out high-speed testing and really push things to the limit. So it's really, really convenient. In the engine system, we actually have a few interesting patents.
Okay.
We're working very much with a new type of valve technology. It's not implemented in production, but it's for the future. So we have like 12 patents within a company within the Koenigsegg group. And then we have turbo patents, a kind of a new type of variable turbo that very much reduce back pressure when connected to catalytic converters, and let's say puts the spool up point at lower RPM and gives better response. So if we go around to the other side here, you can see this little R thing here. That's actually a flex fuel sensor.
Okay.
So depending on what fuel the driver puts in the tank, it comes in here and it's sensed, and the whole engine management is reprogrammed depending on what's entering the into the engine. So the whole fuel management system is geared to handle massive amounts of fuel, as alcohol has less energy density. So let's say that if we only would run on petrol, the pumps, the injectors, everything is kind of sized for over 2,000 horsepower. But when you run on alcohol, it's a good safety margin, but we can get around 1,200. So we didn't realize it until recently, but this is actually the most downsized engine in the world of any production car engine. We have, when you think of it, it's a 5-liter engine, and we have almost 1,200 horsepower. So you have, like 228 horsepower per liter engine volume. That's 33% higher than any other production car in the world. We have 240 Newton meters of torque per liter, which I don't know exactly what it equates to in foot-pounds. We have 6 horsepower per kilo engine weight, which is 100% more horsepower per kilo than the nearest other production car engine.
Ready? Yeah. That's no hands.
It's incredible how it's so steady at low speed. Oh my God.
That was 315. And you don't need to hold the steering wheel when you brake either, because it's so stable in a straight line. Yeah. So,
this is station 4 here.
4, okay.
Yeah, so here the monocoque comes clear coated in the areas needed from the paint shop. And we kind of fit a lot of wiring harnesses, electrical systems, dry sump tank,
got it.
Oil cooler, air conditioning condenser. This is kind of interesting. We have a lithium iron, not ion, lithium iron battery because it's safer instead of normal lead-based batteries. Okay. So it basically has half the size and a third of the weight. And we put it very centrally in the car, even though it doesn't weigh that much anymore. It's still in the center part of the car to try to keep the mass in the center as much as possible. This is also why the fuel tanks are actually inside the carbon monocoque. So the fuel tanks are in here, the back and there, and it's only one piece, like a big horseshoe tank.
Oh, so they're all physically connected?
Yeah, you only fill up.
Separate tanks.
No, you only fill it up at one point. It's one huge tank like that. And this is, as far as we can see, the absolute best position for a fuel tank, because it's again central. Most of it is extremely low down, and it's definitely in the most safe area of the car. It's protected by the monocoque, being inside the monocoque. And that makes it very complex. It's like almost an aeroplane fuel tank, if you consider them being in the wings. Even though we don't have a roof helping out as a stiffening structure, as far as we are aware, we have the stiffest carbon monocoque, whether it has a roof or not, because it actually has 65,000 Newton meters per degree stiffness. And if you look at how massive these sections are, it kind of becomes understandable. Of course, if we would put a fixed roof in, it would even better, but it's still extremely high. Inside there you have the honeycomb, and then you have this massive sections and 21 layers of carbon fiber, unidirectional in the correct direction. So it just becomes extremely stiff and strong. And the weight of the chassis is under 70 kilos, including fuel tanks. So, and this is also pretty extreme. The windshield area and the roll bar, it's all carbon fiber. There aren't really any metal parts here. Of course, power means heat, and a large portion of our market is in a hot climate like the Middle East and so on. And we heard many horror stories about even famous brands, big car manufacturers having issues in those regions. And our first customers came from that region, and they said, whatever you do, put as big of a water radiator that you can. And we told them, well, okay, we've calculated we need a certain size and we've tested. And they said, forget about that. Put the biggest you can. Everyone calculates and tests. That doesn't mean anything. Just put a huge one in. So we managed to kind of extend it this much from our calculation. We've never ever had any issues. Even parts like this that look standard are actually specially manufactured to control airflow out of the car. So this is just a water bottle, but it's our own.
Yeah, it's very cool. Thank you, Robert.
You're welcome. I could show you some cornering as well.
Sure. Why not?
That was 220.
220 sideways. The best job in the entire goddamn world. Robert, you really are. At 24 years old, you are one of the luckiest people to ever face this earth.
I know.
You're very lucky. Thank you so much, Robert.
You're welcome.
It was such a pleasure. I've never been in a car that is that fast at speed and in the turns. It's incredible.
The gearbox is partially developed by ourselves. It's manufactured by a company in Italy called Cima, and we've developed our own electronic differential.
cool.
Sitting on the side, you can see this black cover. So we can actually adapt differential locking depending from our own ECUs, depending on setting of the driver or driver behavior and track and so on. And then we have here, it's not mounted right now, but in here it sits a hydraulic clutch. We call this the first single input shaft dual clutch gearbox. When we shift, at the same time as we open the clutch here, we have this hydraulic clutch sitting on the same shaft, which kind of works in the opposite direction. It actually closes against the casing to slow down the input shaft so that we can push the synchros much harder because it's already pre-synchronized. So it basically takes out 2/3 of the synchronization time. So it's not that it's zero shifting time, but it's close to, and it's so close that you hardly can notice it anymore.
I always thought it was very cool, this gauge on the side.
Right, yes. Yes, this is of course also completely custom.
So, whose idea was this?
That was my idea. Because we needed a custom expansion bottle.
Yep.
And it's pretty much hidden. And normally these are made in plastic, but it didn't really make sense to do. We used to have one in plastic earlier on, but you would have to look from the back and you couldn't see it. And we wanted a fabricated one that was really more optimized to the shape of the car. And then I came up with the idea, you can actually see the level through a tube with a glass on it. And here you can see also the Triptych Suspension, which is one of my ideas I had. And the reason for it basically is that the more power we got, well, okay, you saw, in the engine room you saw the wishbones. Yes. And we decided early on not to have anti-squat geometry because we had fairly stiff springs, the car was light, and it didn't squat very much, and we want a little bit of squat for traction. But as the power increased over the years, the car started squatting a bit more and more, and to a degree where we felt it was a little bit too much with the latest power level. So instead of building in an anti-squat geometry into the suspension, which has downsides, it actually upsets other parts of the suspension. I came up with this idea that we put in an anti-squat damper instead, which we call the Triptych Suspension. So when it's squat, it actually pushes from both sides, and it means double the speed compared to the normal shock absorber. So it calms down the squat, but it doesn't, in cornering, do anything. It just goes sideways. Unless you hit something with one wheel, it starts doing a little bit. So it's about fine-tuning. It's kind of a new dimension, another dimension of shock absorbing compared to just having two separate ones. It adds a little bit of weight, but it maintains, it controls the squat, and it maintains a very clean, true suspension geometry. You can only drive really fast if you feel safe and if it's easy to control. You can see how very calm it is with this enormous power. It's totally controlled. I mean, when we did this world record in braking and acceleration, you can do that record basically with a finger on the steering wheel. Full brake from 300. You don't have to, it doesn't do anything like this. It's just tracks solid, yeah.
I got it.
This is also our own product. We even go in and engineer all the switch gears and everything inside this paddles because it needs to have the right feel. I want to kind of a trigger feel of
yeah.
You can't go halfway. It's either you pushed it or you haven't.
Yeah.
So it's a very clear, distinctive feel to it. And then underneath this leather, it's actually a foam core to make a soft grip, and underneath that it's a hollow carbon structure made in one piece. This is what we call alignment PDI test driving. Actually this station go all the way over there because that's the washing area. We have wheel alignment, corner weighting, and then the test track outdoors. Here we take care of our test cars, our prototypes, but we have 4 service mechanics in here, and they also service customer cars. For example, where we have customers where we have no dealers, we either fly these guys out there to service the car, or they fly their car here to service their car. But usually when they take the car here, they also upgrade them. We have upgrade programs for for the CC8S, the CCR, the CCX, the CCXR. Basically, you can upgrade a CCX to a CCXR, an Agera to an Agera R, a CC8S to a CCR engine, if you like. And there is some cross, even though there is big differences between a CCR and a CCX. It's actually a completely new chassis and completely new body, completely new electronic system. They look similar but are different. But some systems can be adopted backwards. So we keep the earlier cars really fresh and alive and modern by implementing the latest technology we have for them. And as it's being done here at the factory, it's not bastardizing them. It's actually original equipment. But it's making them, well, stay alive and fresh, basically. We started producing cars in 2002, and now it's 2012 when we built 100 cars, well, over 100 cars this year. But in 2002 we built 3 cars, in 2003 we built 5 cars, in 2004 it was 7, 8, so it's of course grown over the years, but on an average around 12. So.
And this year, how many do you think you'll produce?
Hopefully a little bit more.
Okay.
Yeah. You saw the steering wheel down there, and we first designed it here, printed out, feel it. Then I had some ideas about this shape, so I reshaped this by hand. And then we have a laser scanner, so we scan that back in, get into the computer, and then print out another one and test it again until we're satisfied. So we can go from 3D CAD to physical model, modify it by hand, putting it back in 3D CAD with the hand modifications, re-engineering it, and then out again, and then okay, couple of iterations, and then we're done. So it's really nice to touch and feel and see in reality. It really changes everything. If you only do it on the screen, it will never end up exactly how you want it in the end. You have to have this fast, simple process of going from virtual reality to reality and then back again.
Got it.
I found a fantastic factory 10 minutes away from here, which was kind of a rebuilt old farmhouse with marble floors and thatched roof, and it was like 20,000 square feet. It was perfect. And we started there. However, in 2003 we had a fire, so the building got pretty much destroyed. We managed to save most of the equipment and the parts while it was in the fire. I mean, we just got everything out. And then this was still a military area, so the mayor came to the site. It was a Saturday, and we were all kind of suited up and said, well, we managed to get most of it out, but now we don't have a building anymore. And they said, I'll talk to some people at the military base. So we actually got into one of the buildings next door here that was already cleared out because they were shutting down. And that, ironically, was the fire station. It used to be the fire station. And we first planned to rebuild our first factory because we really liked it. But when we got all the plans for it and how long it would take like 1 to 1.5 years to get it done. And we would have to set up temporarily here, and we did that at the first site. And we realized if we're going to make this work and start producing cars and then move again, we're never going to get going. And then we had the look here. There were still airplanes in here, and they said maybe this could be something for you. And say, yeah, that looks pretty interesting. It's not as quaint and elegant that the place we used to have, which we really liked, but it's kind of practical. And of course, people think, well, then you got access to the test track, which is not true, because we already had access to the test track. Actually, the gate to the test track is closer to where our old factory was than where this is. So that had nothing to do with it, because it was just next door anyway. But it's practical, it's nice, it has the heritage of the airplanes. And we got the Ghost. When we moved in here, we got the Ghost. If you
that was going to be my final question. What is the Ghost?
Yeah, that Ghost was on that wall when we came in here. And you see these lines here on the floor, it's where they taxied in the airplanes.
Got it.
And that's actually the symbol for the squadron that used to be here, which was the oldest airplane squadron or fighter jet squadron in Sweden from like the 30s or something like that. And they were called the Ghost because they had before they had kind of modern aviation electronics and so on. They just flew on their senses, and they took off before dawn. And people could only hear them and not see them. And then they came back after dusk. So they heard these airplanes but didn't see them. And of course, airplane was quite a new thing then. So they were called the Ghost. So they adopted this symbol. And for some reason, very early on, they adopted a slogan, "The show must go on." And they wrote that on their airplane, in English even. And then the show stopped. And we came here, and some of the people working here with the airplane said, "Please, can't you continue our tradition, put our Ghost on your car, then the show will go on." And they said, okay, yes. So we said every car we will build here, we will put the Ghost on to honor the squadron. So that's the story.